So like getting the machine, unboxing the machine, easy. I honestly, the machine was up and running in an hour. The hardest part of the machine was moving the machine because it's beefy.
It is.
It is super beefy, but I appreciate
200
that.
pounds of solid steel.
Yes, it is. So hauling it from the garage through the house into my office. Hey, buddy, can you come over and let's manhandle this?
Yeah.
The machine, honestly, feels a little intimidating when you get it and you're stepping into this larger format, higher capability. It does. It feels a little intimidating, but once you start working with it, it's good.
Yeah.
It's easy to interface with.
Little things like the terminal blocks, right? For a new user or somebody who's not super technical, just looking at the hot ends with these wires coming out and the terminal blocks, one of that could be intimidating.
Yeah.
But it's there so purposeful in that it's faster, easier maintenance. It's full accessibility.
Yep.
You want to add some more terminal blocks on there? Be my guest. You can modify this thing however you need.
Yeah, I mean, accessibility, servicing, pretty straightforward. Getting the machine rolling, I started with the 0.6. I kind of skipped past 0.4 because of the scale of the project I was working on. I knew I needed to get straight into high-level production, tuning exactly with how I'm going to print.
Right.
And then designing the parts around how the printer would produce. So it's been kind of a
designed for manufacturing.
It's designed for manufacturing,
additive manufacturing.
and I'm very experienced in casting and different types of plastics and aluminums and machining. Then designing for end use functional 3D printing, I had to like stop and reset a little bit.
Yeah.
And that's where layer width, layer height, those types of measurements and understanding what's printing well with that 0.6 nozzle, what's my line width. Okay, I need to make sure I have optimal strength and the print is as simple and straightforward as possible. So once I felt like I had the printer dialed in on the material, then it went back to my part design and said, is this optimized for how the print is going to produce?
Right.
So then a lot of my parts were thin wall, big structure. We're talking big square kind of arching ducts, right?
Yeah.
The first version, they failed. The design was not right.
The part would not print.
Because my brain was designing with a wall thickness that was too thin for additive with the way the nozzle performed and how it extruded in its line width.
Right.
So I had to actually go back and go, okay, right now I only have 3 walls in my structure.
Yeah.
And if I increase this up to 5 walls and match the line width of the extrusion, now let's do a test print. Oh, wow. Leaps and bounds stronger, much more durable, can handle vibrations. If you don't consider those things an additive, then you may be missing a big opportunity with it.
I think this is where a lot of people still struggle, or manufacturers, big and small, especially ones that have, maybe they've gotten to 3D printers, their parts didn't come out well, and they just cash it off as, whatever.
Yep.
And it really comes down to that mindset of, design for manufacturing, design for additive manufacturing, DFAM, right? Just a little bit of effort in that makes a world of a difference. I mean, even if it's just changing that, okay, you got a 90-degree overhang that goes over and then it goes up. Okay, just throw a 45-degree on there.
Yeah, throw some chamfers in.
Stronger, faster, better layer adhesion, everything.
And so that's a great point. Shifting the design, when I'm designing the part and orienting it in CAD, how I think I'm going to print it, looking for issues or things that will require support that's just a waste of time and material, adjusting the CAD immediately from that viewpoint so that when I bring it into the slicer, I'm already 90% there of optimization.
Yeah.
Then I go through slicing it, try different angles, orientation. Oh, look, I have support here. Or like, I don't like that it's not carrying the wall thickness through this section. What are the adjustments I make? And then maybe I bring it back into CAD. I make some more adjustments to the model because sometimes optimizing the part for printing has no negative effects to how it performs.
Right.
But it makes the part print better.
Yes.
And that's important.
Right.
And sometimes you don't have a choice. And you just have to have support material, and it just is what it is, right? Because the functionality of how the part performs in its end use is more important. And I get questions like that on Instagram. Oh, why do you have so much support? You could position it this way. But you're not considering all the variables that are going on here. Yeah. You have to, when you move into the functional space, instead of just, this is just a rapid prototype and all it has to do is work for 30 minutes.
It's fit right.
And fit right.
Yeah.
if you go beyond that, and it's like, how does this operate? What are the forces going through the part?
Exactly.
You have to change your focus a little bit, which has been honestly a really fun challenge to learn about, understand, optimize, try, test, the whole process.
Right.
I mean, as an engineer, it's just exciting.
You know, I like to sleep well at night. So when somebody asks for a print service on a part, it's like, we could just print it and send it, or like just, okay, cool, give me your money and do. But it's like, if it's not optimized, which most of the time it's not, it's like we always are just like, we want to make our own lives easier.
Yeah.
And so we go back and we consult, hey, if you just do this and that, and we have to ask the questions too. We'll get parts. Hey, cool. Yeah, it's for a thing. We're like, great. What's the environment it's in? What are there forces being applied? In what direction? Okay, here's a couple options. If we print it this way or that way, it'll be stronger this way or that way. And a lot of times they'll go back to the drawing board and actually be like, dude, yeah, thank you so much.
Oh yeah.
And then, you know, we'll either do print service, or they'll just buy a machine and do it themselves for ROI insane.